Hello friends, just look at how interesting and nice exercise we have here. It's a figure where we need to find the shaded area. The exercise tells us knowing that all the shapes are squares, find the shaded area. So all of these here are squares. As always, you can solve it in your notebook and leave me your answer in the comments. Let's go to the exercise. The first thing we are going to do is remove the shaded area so that what we are going to be placing can be seen. Ready? In the end, we'll return that. Now notice this measurement of 13 is from here to here. So here is the side of a small triangle. Notice it's a right triangle if there is 90 degrees here. So we'll call this side, on this side here of the triangle, we'll call it B. And this side, which would be the triangle's hypotenuse, we'll call it C. But this side, which is the hypotenuse, is also the side of these small squares. Now then, let's see what we have around here. Around here, we find that we don't know what these angles are, so we'll just name them. I'll call this angle here angle theta, and this angle here high angle. Now we have that the three angles of a triangle must give me 180 degrees. That is the 90-degree angle we have here, plus the theta angle, plus angle alpha should give us 180 degrees. Fantastic. Now look over here, we have a 90-degree angle because this is a square, so there are 90 degrees here. And here, this angle, we don't know how much it is. We're going to erase it to make this angle bigger. We don't know how much it is, but we know this from here, and by adding the 90 degrees we have here plus alpha and plus this angle here should give us a 180 degrees because it's a straight angle. From here to there are 180 degrees. So then it should give us 180 degrees plus this and that. And what are we missing here? We're missing the theta angle because here we had already said that 90 degrees plus the alpha angle plus the theta angle equal 180 degrees. Here we have 90 degrees alpha angle. The only thing missing is the angle T. So this here is the angulo tetra. Over here, we also have 90 degrees because it is a square, as we mentioned. So this is a right angle. And this angle here, which angle will it be again? Let's visualize this. We have a 90-degree angle and we have theta. And what do we have? We're missing something. And there we have completed the 180 degrees. That all angles of a triangle added together must have. So at the time of we have this from here. And something more, also notice this side of the square measures CE. So how much does this hypotenuse measure? Then, well, I have C plus C plus C and more. So the entire hypotenuse measures 4 times C. Very well. And notice that this triangle here is similar to this triangle there. We're just going to flip this triangle like this. Take a look. This here will stay here 90 degrees here. And then this one here will stay up here, this theta angle. And so this alpha angle will be at this point here. And now you can see that it's identical to this triangle here. We have 90 degrees here, we have angle theta up top and angle alpha down below. And since it's a triangle that is similar, so let's see what the ratio of this small triangle to this big triangle is. This large triangle is 4 times larger than this small triangle, as we know it from the hypotenuse. Look at the hypotenuse of this small triangle is C, and the hypotenuse of this large triangle is 4 times C. So this big triangle that I've drawn here a bit smaller is 4 times bigger than this triangle here. Therefore, if we have that this side here measures A, in our big triangle it should measure 4 times A. But what is this side? It's the side that connects the 90 degrees with angle theta. In the case of the large triangle, it would be this side here that connects the 90 degrees with the theta angle. Therefore, we can say that this here is 4 times this side of the large triangle. And what will this side over here be? Since the triangle is 4 times larger, this big triangle, it must be 4 times larger than the side corresponding to the small triangle, which would be this side B that connects the 90 degrees with the high angle. Here we have 90 degrees, and here we have the alpha angle, so this is going to be 4 times B. Alright, now we have all the sides of this daily triangle. Here we are going to use some equations to determine the side of this triangle and also the low blood pressure. Let's delete this from here. Very good. Now we're going to use Pythagoras on this big triangle. Notice, we're not going to use any of this yet. We're just going to use the big triangle. So what's the hypotenuse of this big triangle? It's 4 times C. Thanks to Pythagoras, we know that the hypotenuse, which is 4, C squared equals the sum of the two legs. This is one leg. So 4B, the sum of the two sides squared, right? So we have 4B squared. And the other side is this one here plus 4A. Also squared. Very good. What else do we know? Look, this side of this square must be equal to this side of this square. Because it's a square, all its sides must be equal, right? So we have 4B here, and over here we have 13 plus A. So 4B must equal 13 plus A. What else do we know? Well, we know that this side here must also be equal to this side over there because it's a square. So we know that 4B equals... how long is this side? Look, from here to here it measures 20 centimeters. And from here to there measures 4A. So all together would be B. Plus 4 times, very well, we have several equations. And from here we can already clear some things up. So let's go ahead and clear B on this side, or we're going to solve for A. It doesn't matter which one we solve. We're going to move this B to the left side of the equality, and we get 4B minus B equals 4A. Alright, so we have 3B equals 4A, and clearing thus all remains on the other side. Dividing this 4 leaves me 3B fourth. Really good. This is what's worth. Fantastic. We've got it. Around here then an equation just with 2 variables that we can substitute in any of these other 2 that we can replace. We can substitute it in this equation here. Notice this one here. So we have this here, and wherever we have we are going to put 3/4. So how does this leave us? Let's put it down here. Pay attention to this from here. I'm going to put it here. We have 4B equals 13 plus A. But how much is it worth? It's worth 3.24. Very well. This over here will remain on the left side of the equality, and we get 4B minus 3B 4. And this is going to be equal to 13. Perfect. Now pay attention. We multiply this 4 by this green 4 here, and it gives us 16 times. And then we subtract these 3B's from here. How much does that give us? 16 minus 3 is 13B. And 13/4. Because we need to put this 4 here. This is a method to solve when we have a whole number and we are already subtracting a fraction. If you want, you can use the other method by putting a 1 here and then applying a sum of fractions or subtraction of fractions. Very good. So we are left with 13B/4 equals 13. And we're going to solve for B, so we get that B will be equal to 3, which is this 3 here. This 4 is on the other side by multiplying, and this 13 here is by dividing. Very good. We can simplify, and we have that V equals 4. Very good. We already have a variable. We know its value. It's 4. And now we can know how much the other variables are worth, simply because we have to replace this 4 anywhere, not here. We can replace it. Notice if we replace here, we're going to put it over here. We have 3B/4 equals A. So replacing B with 4, we put 4 here. We simplify, and now we know that A is going to be equal to how much? To 3. Fantastic. Now we know how much it is worth. How much is B worth? And then we can find out how much C is worth. Over here, from this equation, we're going to place it over there to this equation. So we have 4C squared. 4 squared is 16. Let's move it a bit further up, okay? We'll put it here. Then 4 squared is 16c squared. And this is going to be equal to 4 times b. And how much is b worth? It's worth 4. So here I get 16 squared. 16 squared plus 4 times, but how much is it worth? It's worth 3. So I have 4 times 3, which would be 2. 12 squared. Very well. Then we have here that we can divide everything by 4. We can divide everything by 4. Let's write this in another way so it's more visible what we're going to do. So we have here 16c squared. Pay close attention and we'll divide this by 4. Let's make this line a bit straighter. Ready? And this is going to be equal to 16 squared, which is 16 times 16. We're going to write it that way. 16 by 16, this over 4 plus 12 squared can be written as 12 times 12. And this above all, 4. We divide the whole equation by 4 and broke down this 16 squared and this 12 squared to simplify more easily. So what do we have left here? Quarter 1 and quarter 16. 4c squared, we have on the left side 4c squared. Okay, and on the other side we have quarter 1 and quarter 16 is 4. Very good. Then quarter 1 and quarter of 12 is 3. Ready? So what do we have here? 16 times 4 equals 64. And what do we have over here? 12 times 3 is 36. 64 plus 36. Well, that is 100. Fantastic. And we already have the solution to our exercise. Look, this one here is the shaded area. Impressive, but as a teacher, let's return then the shaded area. Ready? What was it that we needed to find? The area of all of this here. And I ask you, what is the area of each of these small squares? C times T means C squared. That's the area of each square. And how many squares do we have? 4. So the total area of all this part here would be 4 times C squared. And that is what we have around here, 4 times C squared, which are 100 here. We can put units squared because it is about fantastic areas. Let me know in the comments if you liked the video, and don't forget to subscribe and hit like so you don't miss the next challenge. See you another time. Bye bye.